So I just wanted to do an example of a type of problem that we've been practicing in class. And that's if I give you 2 points, how do you find the equation of the line that goes through those 2 points? So what I'm going to take advantage of is what I know about this slope-intercept form of an equation, y equals mx plus b. I know that the slope is m. I know that b is the y-intercept. And I know also that any point in that line is going to be a point xy. So 5, 7, right? 7 is y, 5 is x. That'll be a point on this line. 3, 1. 1 is y, 1, 3 is x. That's a point on this line. So first thing I'm going to do is try and find the slope. So first thing I'm going to do, try and find that the slope. And one of the things I know about slope is it's the change in y over the change in x. So let me try and do that. The change in y, 7 to 1. Change in y, that's going down, so that's negative 6. Change in x, 5 to 3. That's also going down, that's negative 2. So I know that slope is change in y over change in x. My change in y is negative 6. My change in x is negative 2. A negative divided by a negative is positive 3. So my slope's 3. So next thing I'm going to do is plug that in. Plug m into the equation. Because right now I know how steep that line is, so I might as well keep track of that information. So y equals 3x plus b. So now the next thing that I have to do is find the y-intercept. And the way that I'm going to find the y-intercept is I'm going to take one of the points and plug it in, and then I can just solve for b. So basically what I have here is a steepness. I have this line that has a certain steepness, but I don't know where the y-intercept is yet. So in a sense, what you can think about what I'm doing, it wasn't going to work like I thought it would. What you can think about what I'm doing is I'm basically trying to grab this line that I know the steepness of, not change its steepness at all. I have this line that has a certain steepness. I'm not going to change its steepness at all, but I'm just going to figure out how high or how low on the graph it is. I'm not changing the steepness, I'm just changing the b. So the way again that I find the b, the next thing I'm going to do is I'm going to plug in one of the points. So I can pick either one. I'll just pick this one just because. Points come in the form xy, as you know. Y is 1, when x is 3. And now I can solve this for b. 3 times 3 is 9. Subtract 9 from both sides. Negative 8. Looks like b is negative 8. So the fourth thing I did was I solved for b. And then the last thing I'm going to do is write the equation with the pieces that I know. I know m. I know b, and I'll have my equation. So it should be y equals 3x minus 8. And that is the equation that goes through those 2 points. And I can always check them, right? Plug in x for 5, plug in y for 7, left will equal right. So here's what's nice about this, is you have this procedure that you can use even if you have a different problem. So let's just grab a different problem and see if we can run it through the procedure and then see what happens. So let's say I have the point 2, that's a comma, 2, 9, and then let's make this 8, and let's make this into a, sorry, I don't know why this is so hard for me, 7. All right, let's see what happens. Find the slope. Change in y, 9 over 7 is negative 2. Change in x, 4 up to 8 is 6. So, plug m into the equation. Oh, I haven't found it yet. The slope is change in y over change in x. My change in y is negative 2. My change in x is 6. That's the same as negative 1/3. All right, plug it into the equation. That's a G. Where did that come from? Poor handwriting. Y equals negative 1/3 x plus b. All right, pick a point and plug it in. I'll pick this one. X is 2 when y is 9. Y is 9, x is 2. Negative 1/3 times 2 is negative 2/3. I plugged it in, and I'm already solving for b. Add 2/3 to both sides. 9 plus 2/3 is 9 2/3. Boy, that is an ugly 2. 9 2/3 is b. So I solved it for b. Now I know my pieces. Y is negative 1/3. And then my intercept is 9 2/3.